All right, so we're going to talk about limits today and finding limits using a graph and doing some t-table work as well. So we're going to start off, we're going to look at the definition of a limit, and the definition says that the value that y approaches, and we're going to call that value L for now. So some value of y that y approaches as the value of x gets closer to some number, and we're just going to call that number c. Okay, so we're going to talk about that definition, but the way we write that is we would say the limit as x approaches c of your function equals some value of L, and that value of L is a y value. Okay, so a limit is a y value. So if we take a look at this first example on the right here, we've got the graph of f of x equals sine x over x. We want to find the limit as x approaches 0 of the function f of x. Okay, so this is asking you to find the y value as x approaches 0 from the left and from the right. So we're going to start off by looking at what happens so as x approaches from the left. Okay, so as I walk along this graph from the left over towards 0, I would say as x approaches 0, and you can see that as I get closer and closer to 0, I'm looking for the y value right here at the top. So I would say that y approaches the value of 1. So on the left side of the graph, I'm approaching 1, and you're probably sitting there saying, well, you're doing the same thing on the left, because now as x approaches 0 from the right side, okay, so this is the right side of 0. So if I were to walk along the graph this direction, as x approaches 0, y is approaching 1 there also. And you'll notice the notation changed a little bit right here. It says as x approaches 0 from the positive side. That means from the right side. The other one was x approaches 0 from the negative side, which is the left side. So we would say that that limit, okay, the limit as x approaches 0 of f of x, we would say that this is equal to 1. Okay. We could also do this using a calculator, doing some numerical limits, and so I'm going to do that in my calculator. I'm going to go ahead and graph our function from above here. Remember, it was sine x over x. So I've got my calculator. I went to my y equals. I punched in my equation right here. And now what I want to do is I want to take a look at some of these values here. So I want to plug in -1, -0.5, -0.1, and I want to see what's happening with f of x. As you'll notice here, I'm going to get closer to -1 or to 0 from -1. Then I'm going to move in a little bit closer to 0 at -0.5, a little bit closer to 0 at -0.1, and a little bit closer at -0.01. So that's what I want to do with my calculator. Now there's a couple of different ways you could do this, but I'm going to go ahead and go to my home screen here. And if I simply hit alpha and trace, and I pull up my equation because I graphed it in y1. So I'm going to pull it up, and then I'm going to tell my calculator to do the value at -1, x equals -1, and it's going to calculate 0.8414. And I can do that again, alpha, trace, y equals, and I can calculate at -0.5. That was my second value. And you'll notice it jumped closer to 1 from there. And I'll do one more here, alpha trace, number 1, and we'll do -0.1. Okay, and I can continue to do that with as many values as I want, but you'll notice that these values, as x approaches 0 from the left side, these values are getting closer and closer to the value of 1. So if we were to actually fill in the chart, we would get 0.84147. The next one is 0.95885. The next one is 0.99833. If we were to do the next one, it would actually be 0.99998, which is awfully close to 1 there. You can see that. And then if we went to the other side and we did the same thing, we're going to get the same values. You saw the graph up above, 0.84147. Then we're going to get 0.95885. Then we're going to get 0.99833. Then we're going to get 0.99998, very close. And then we want to do 0 as well. Now you might be thinking, well, it looks like it's going to be 1, right? But if I actually do alpha, and I pull up my equation again, now I want to punch in 0. It tells me that I have a problem. It tells me that I'm dividing by 0, and there's an issue there. And I can't do that. I can't divide by 0. So you will see that when I plug in 0 to this equation, I get sine of 0 over 0. We can't have that. This is not defined. Okay? So I am not defined at x equals 0. So there actually is a hole in my graph right there, but the limit is still 1. So as you saw above, the graph approaches 1 from the left, it approaches 1 from the right. My t-table shows that it approaches 1 from the left as well as 1 from the right, even though when I actually get to 0, okay, f of x is still approaching 1 as x approaches 0, but f of 0 may not necessarily equal 1. It does not have to. So we would still say that the limit as x approaches 0 of f of x, okay, in this case that was sine x over x, equals 1. All right? So when we have limits, we can look at limits graphically, we can look at them in a chart, we can look at them various ways. So it says a limit exists when both sides of the graph meet at the same y value. So both sides meet at the same y value, even though there might be a hole at the y value. Okay? So again, that's all I'm looking for. I want to know, where does the graph meet at a certain value of x? So this next one says the limit as x approaches 2, okay, of f of x. All right, well, here's 2 on the graph right here. So if I approach from the left side, okay, so coming down from the left, as I get closer and closer to 2, to x equals 2, my graph, the y value, is getting closer and closer to -4. And if I approach from the right side, the positive side, okay, so this side also comes down and approaches the value of -4. So we would say that the limit is -4. Okay, I go to the next one. I do the same thing. X approaches 2. Now you'll notice I've got a slightly different graph here. Looks like half of a parabola and a straight line. So I can do the same thing though. It doesn't matter. As x comes down the left side is approaching the value of -2. As I come down the right side, or the positive side, that side is also approaching -2, so we're going to say that the limit is -2. I'd go to the next one, and all of a sudden, I've got this jump in between here. I've got a discontinuity here. So as I walk down the left side of this graph, okay, and I approach x equals 2. So here we go. X approaches 2 from the negative side. This graph from the left side is approaching a value of -2. But if I walk down the right side of 2, I'm not going to approach that same value. Now I'm approaching a y value of 0 from the positive side. So if I'm approaching 2 different values, then we say that the limit does not exist. Last one, if the graph Look at the definition up top. A limit exists when both sides of a graph meet at the same y value. This graph meets at the same y value. The left side's coming down and approaching 0. The right side's coming down and approaching 0. Therefore, the limit is 0. I would encourage you at this point to turn off the video, maybe try these on your own, and then come on back, and I'll have the answers ready to go for you. All right, so number one, the limit as x approaches 0. Okay, so here's my graph of g of x on the right. So if I approach 0, I'm coming up from the left, down from the right, and I'm approaching a y value of positive 3. The next one doesn't say limit, it just says what is g of 0. G of 0 means a point. 0 is x. They're saying give me the y value now. Well, the y value there also happens to be 3. There's no hole right there in the graph. Okay? Next one, the limit as x approaches 1. So now I'm approaching 1 from the left, 1 from the right, and both of those graphs meet at a y value of positive 4. However, this time the point is only defined at y equals 1 right down here. Okay? All right, notice the next two. Number 5, what's the limit as x approaches negative 4 from the negative side? So here we go, negative 4 from the negative side. So I'm approaching negative 4 from the negative side, and my y value is approaching that open circle at positive 1. I go to the other side, the limit as x approaches negative 4 from the positive side. So now I'm walking towards negative 4 from the positive side, and my graph approaches a y value at negative 1. So what's the limit as x approaches negative 4 g of x? Well, if these two guys above were the same, I could say that the limit was 1 or negative 1. But because they're not the same, we would say the limit does not exist. Okay? And the reason it does not exist, okay, we're going to be writing lots of these in the future, because the limit as x approaches negative 4 from the negative side of g of x does not equal the limit as x approaches negative 4 from the positive side of f of x. Or excuse me, g of x looks like. All right. Next question, what's the value at g of negative 4? Notice the open circle at 1, the closed dot at negative 1. So g of negative 4 is defined at negative 1. And then we go over to positive 4. We're going to look at the limit as x approaches 4 from the negative side. So the negative side is the left side. So you'll notice this time I'm approaching, but my graph just keeps going up and up and up. So I'm actually approaching infinity. If I go to the other side, 4 from the positive side, I'm still approaching infinity. So you might say that the limit is infinity, right? Well, infinity is not a number, guys. So we would say that it does not exist. Now, there will be questions where it asks you, does it approach positive or negative infinity? But you can always say it does not exist. And there you go.